Vector 0, the defense protocols against Nipah. It sleeps in the canopy, a microscopic assassin boasting a fatality rate that paralyzes epidemiologists. Nipah is not just a virus, it is a biological sledgehammer capable of shattering the species barrier with devastating efficiency. With no cure and no vaccine, humanity's only shield is rigorous, uncompromising prevention. This is an investigation into survival, dissecting the behavioral firewalls necessary to stop a level 4 threat in its tracks. To secure your perimeter, we must first confront the primary reservoir where this contagion thrives.
Entry 1. The primary vector, total avoidance of bats and wild animals, the biological reservoir and the zoonotic interface. The first and most critical line of defense against the Nipah virus is the absolute non-negotiable avoidance of its primary biological reservoir, the fruit bat, specifically of the genus Pteropus, colloquially known as the flying fox. To understand the gravity of this prevention protocol, one must first comprehend the terrifying efficiency of the host. These are not merely pests, they are evolutionary marvels that have co-evolved with some of the deadliest pathogens known to science. Bats constitute roughly 20% of all mammalian species, and their physiology is a unique anomaly in the animal kingdom. They are the only mammals capable of true flight, a metabolic process that generates immense internal heat, temperatures that would induce fever and organ failure in humans. This hypermetabolic state has seemingly trained their immune systems to tolerate viral loads that would incinerate the biological defenses of other species. Consequently, they act as asymptomatic reservoirs for henipaviruses, maintaining the pathogen in a state of stasis until it spills over into a host that lacks such defenses, humans. The prevention strategy here is not simply about avoiding a bite, it is about avoiding the entire ecological radius of the creature. Nipah is not strictly bloodborne, it is excreted in urine, feces, saliva, and birthing fluids. In the 1998 inaugural outbreak in Nipah, Malaysia, the transmission vector was not a direct bat attack on a human, but rather the proximity of pig farms to fruit orchards frequented by bats. The bats roosted in the trees, their urine and partially eaten fruit fell into the pigsties below. The pigs became the amplifier hosts, increasing the viral load exponentially before passing it to farmers. Therefore, the directive to avoid contact extends to the environment the animal inhabits. In a modern context, particularly for travelers or residents in potential hotspots, this means identifying roosting sites, often characterized by noisy, chattering canopies and a distinct musky odor, and establishing a rigid exclusion zone. One must never handle a downed bat, even if it appears dead. The virus can remain viable in a carcass for days depending on humidity and temperature, waiting for a scavenger or a curious human hand to facilitate its next jump.
The mechanics of spillover and environmental contamination. The scientific imperative for avoidance is rooted in the spillover theory. Research indicates that viral shedding in bats is not constant, it is episodic, often triggered by ecological stress, such as deforestation, food shortages, or pregnancy. During these periods, the viral load in the bat's excreta spikes dramatically. If a human touches a surface, a railing, a tool, or vegetation, coated in fresh bat urine, the virus has a direct pathway to the mucous membranes. The Nipah virus enters human cells by binding to the ephrin B2 and ephrin B3 receptors, proteins that are abundantly expressed in the endothelial cells regulating blood vessels and neurons. This is why the disease manifests with such terrifying duality, severe respiratory distress coupled with fatal encephalitis, brain inflammation. By handling a wild animal, one is essentially inviting a neurotropic assassin to bypass the skin barrier. This protocol also encompasses other wild animals that may act as intermediate hosts. While bats are the reservoir, pigs, horses, goats, and even domestic dogs have been documented as potential carriers after exposure to bat excreta. In the United States or abroad, the discovery of a sick or behaving strangely wild animal requires a hands-off policy of extreme prejudice. Do not attempt to rehabilitate, feed, or relocate the animal. The compassion impulse, while noble, is a primary vector for zoonotic transmission. Epidemiological data suggests that a significant percentage of zoonotic jumps occur when humans attempt to intervene in the natural world without barrier protection. The rule is absolute. If it is wild, it is a potential biohazard. The distance between you and the animal is the only guaranteed variable of safety. Post-exposure protocols, the golden hour of decontamination. If the perimeter is breached and physical contact occurs, the response must be immediate, clinical, and aggressive. The virus is enveloped in a lipid layer, which makes it susceptible to soaps and detergents, but time is the enemy. The what-to-do protocol dictates an immediate cessation of all activity to focus on decontamination. If skin contact is made with a bat or its excretions, the area must be scrubbed, not just rinsed, with soap and water for a minimum of 15 minutes. This mechanical friction is essential to disrupt the viral envelope and physically remove the pathogen from the pores of the skin. Following the wash, the application of a virucidal agent such as ethanol or iodine provides a secondary chemical barrier. However, hygiene is only the immediate tactical response. The strategic response involves the medical establishment. Because Nipah has an incubation period ranging from 4 to 14 days, and in rare cases up to 45 days, wait and see is a lethal strategy. If contact occurs, one must seek medical advice immediately. This involves informing infectious disease specialists of the specific nature of the exposure, species, type of contact, scratch, bite, fluid exposure, and location. While there is no post-exposure prophylaxis or PEP specifically for Nipah like there is for rabies, early admission allows for supportive care protocols to be prepped. The psychological burden of this period is immense, as the patient must be monitored for the prodromal symptoms, fever, headaches, and myalgia. The avoidance protocol is in essence a lifestyle of hyper-awareness regarding the boundaries between human civilization and the chaotic, viral-laden wilderness.
Entry 2. The silent trap. Do not eat fruits fallen or bitten by bats. The epidemiology of the windfall fruit. The second entry on this list represents the most insidious transmission route of the Nipah virus, the consumption of contaminated fruit. This factor is particularly terrifying because it subverts a basic human survival instinct, the gathering of food. In many tropical and subtropical regions where Nipah is endemic, and potentially in areas of the U.S. where climatic shifts might encourage bat migration, the windfall fruit, fruit that has fallen from the tree, is traditionally seen as a bounty. However, in the context of Nipah a fallen fruit is often a biological landmine. Terapus bats are messy eaters. They crush the pulp of fruits like mangoes, guavas, and lychees to extract the juice, spitting out the fibrous spat and often dropping partially eaten fruits to the ground. During this process, the fruit is drenched in saliva, which carries a viral load sufficient to infect a human host upon ingestion. This mode of transmission was definitively identified during the outbreaks in Bangladesh and India, distinguishing them from the Malaysian pig farm model. Here, the virus did not need a pig to amplify it. It went directly from bat to fruit to human. The structural integrity of the fruit plays a role in the virus's survival. The sugar-rich, moist environment of a mango or date provides a stabilizing medium for the virus, protecting it from desiccation and UV radiation for a limited window. If a human consumes this fruit raw, the virus is introduced directly into the oropharyngeal mucosa and the gastrointestinal tract. Unlike respiratory transmission, which requires close proximity to an infective cough, oral transmission requires only a moment of carelessness, eating a piece of fruit that looked perfectly fine on one side but harbored a microscopic smear of saliva on the other. The forensic analysis of food sources. Prevention requires a forensic approach to dietary intake. The visual inspection of fruit becomes a life or death skill. A bat bite is not always obvious. It can resemble the peck of a bird or a bruise from the fall. However, bat teeth often leave paired puncture marks or larger gouges where the flesh has been scooped out. The directive, do not eat fruits fallen or bitten, is absolute. It applies to foraging in the wild, harvesting in orchards, and even consuming produce from roadside stands where the provenance of the fruit is unknown. In a high-risk scenario, any fruit found on the ground must be treated as toxic waste. It should not be fed to livestock, as this merely reroutes the transmission chain through an intermediate host, as seen in the Malaysian outbreak. The protocol extends beyond simple avoidance to the processing of the food. Washing fruit, while generally good hygiene, is insufficient to guarantee the removal of Nipah virus if the saliva has permeated the porous flesh of the fruit. The virus can seep into the microfissures of the pulp, placing it beyond the reach of surface water. Therefore, the only safe way to consume fruit in a potential risk zone is to peel it completely, removing the entire outer layer where saliva might reside, and ideally to cook it. Heat is the great sterilizer. Nipah virus is heat sensitive and is inactivated at temperatures above 60 degrees Celsius for 60 minutes or 100 degrees Celsius instantly. Compotes, jams, and cooked pies are safe. Raw fruit salads are a game of Russian roulette. The physiological consequence and immediate remediation. What happens if the protocol is breached? If one inadvertently consumes a piece of fruit and later discovers it was damaged, or bites into a fruit and realizes the texture is wrong, the what to do sequence is grueling. The immediate cessation of eating is obvious, but the subsequent steps are critical. One must thoroughly rinse the mouth with an antiseptic mouthwash or a saline solution to reduce the viral load in the oral cavity. Although once swallowed, the virus is on a path to the gut. The stomach acid provides some barrier, but Nipah has proven resilient enough to survive gastric transit in some cases, or infect through the mucosa lining of the throat before reaching the stomach. The monitoring phase is a 14-day siege of anxiety. The victim must be placed under observation for signs of encephalitis or acute respiratory syndrome. In the absence of a cure, the medical community has debated the efficacy of gastric lavage, stomach pumping if the ingestion was recent, though this carries its own risks of aspiration and spreading the virus. The most effective tool remains isolation. Because Nipah can transmit from human to human, a capability evolved in the Bangladesh strain, a person who has eaten contaminated fruit becomes a potential biological weapon to their family.
They must be isolated immediately upon the realization of the error, even before symptoms manifest. This entry underscores a profound shift in how we must view nature. The romantic notion of eating directly from the earth is obsolete in the face of zoonotic pathogens. The fruit bat does not intend to kill, it is simply feeding. But the intersection of its hunger and human foraging creates a perfect storm for viral emergence. In the United States, where imported tropical fruits are common and local bat populations are shifting due to climate change, the principles of inspecting produce for animal damage are becoming globally relevant. A single bitten fruit, ignored or overlooked, carries the potential to ignite a chain of transmission that can overwhelm local healthcare systems. The defense is simple but requires constant vigilance. Eat nothing that the earth has claimed first.
Entry 3. The liquid vector. Avoid drinking raw date palm sap. The sweet poison, an ecological trap. The third entry in our prevention protocol addresses a transmission vector that is deceptively innocuous yet historically devastating: the consumption of raw date palm sap. To the uninitiated, particularly in the Western world, this may seem like an obscure, geographically isolated risk. However, it represents a fundamental principle of zoonotic avoidance that applies globally: the danger of consuming unpasteurized raw biological products harvested from the wild. In the epidemiology of the Nipah virus, raw date palm sap is not merely a drink, it is a liquid vector, a perfect delivery system for the pathogen that has fueled nearly every major winter outbreak in Bangladesh and India for the past 2 decades. Understanding why this specific substance is so lethal requires a deep dive into the nocturnal habits of the Pteropus fruit bat and the unintended consequences of traditional agriculture. The date palm tree, Phoenix dactylifera, is tapped by shaving the bark and hanging a clay pot to collect the sap that drips overnight. This sap is sweegery, nutrient-rich, and in the cool temperatures of the night, refreshing. Unfortunately, these are the exact qualities that attract the fruit bat. Infrared surveillance and night vision studies conducted by researchers have captured chilling footage of what occurs at the top of these trees in the dead of night. Bats do not simply fly by, they land on the collection pots, they lick the sap as it flows down the shaved bark, urinate into the open containers, and occasionally defecate near the collection site. The result is a pot of sap that by morning has been transformed into a viral cocktail. The sugar in the sap acts as a preservative, and the cool night air prevents the virus from degrading, keeping it viable for human ingestion. The raw movement and the myth of purity. In the United States, the relevance of this entry lies in the growing raw food and foraging movements, alongside the importation of exotic delicacies. There is a prevailing cultural myth that natural equals safe. The Nipah virus shatters this illusion. The consumption of raw sap, known locally in South Asia as tari or kejarella rus, is a cultural ritual, celebrated for its taste and perceived health benefits. This mirrors the Western obsession with raw milk, raw water, and unpasteurized juices.
The lesson of Nipah is that nature is not benign. When you consume a raw product harvested from an environment shared with wildlife, you are bypassing the single greatest technological advancement in food safety: pasteurization. The virus within the sap is insidious. Unlike a bacterial contaminant that might sour the taste or smell, Nipah is undetectable to the senses. A glass of contaminated sap looks and tastes exactly like a clean one. The virus enters the human body through the gastrointestinal tract, a route that leads to a systemic infection, often characterized by a rapid deterioration of the central nervous system. The what-to-do protocol in this instance is rigid: absolute avoidance of the raw product. If one is in a region where date palm sap is harvested, or if one encounters imported fresh sap products in specialty markets, the only safe method of consumption is after boiling. The virus is enveloped and thermal sensitive. Bringing the sap to a rolling boil denatures the viral proteins and dissolves the lipid envelope, rendering it inert. Fermentation, often used to turn the sap into toddy, alcohol, affects the pH, but is not a guaranteed sterilization method for Nipah in the short term. Only heat provides security. The winter phenomenon and seasonal vigilance. Epidemiologically, this factor creates a distinct seasonality to Nipah outbreaks, often referred to as the Nipah season, which coincides with the sap harvesting months, December to March. This provides a critical window for prevention. If you are traveling or living in risk zones during these months, your vigilance must be heightened. The prevention here is not just about personal refusal, but about community awareness. In the US, this translates to a skepticism of wild harvested liquids that have not undergone processing. The risk is not limited to date palms. Any open container collection of plant fluids in an area populated by fruit bats is a potential hazard. If ingestion occurs, if you drink the sap and later learn it was raw, the what-to-do protocol shifts to immediate damage control. There is no way to extract the virus once swallowed. The individual must inform a healthcare provider immediately, explicitly stating the consumption of raw sap from a potential outbreak zone. This information is vital because it reclassifies the patient from a generic flu-like illness to a high-priority biocontainment case. The incubation period can be deceptive. You may feel fine for days while the virus replicates. During this time, the consumer becomes a potential vector for human-to-human transmission. Therefore, the protocol demands self-isolation. You must act as if you are positive until the window of incubation closes. The tragedy of the sap outbreaks is that they are entirely preventable. They occur at the intersection of tradition and biology, a reminder that in the war against pathogens, cultural habits must sometimes yield to biological realities. The global implications of unregulated foraging. This entry also serves as a warning against the unregulated global trade of exotic foodstuffs. In an interconnected world, a jar of fresh organic date sap shipped overnight from a village in Bangladesh to a boutique health store in New York or Los Angeles is a plausible scenario. The virus can survive in sap for days if kept at specific temperatures, conditions often mimicked by modern refrigeration meant to keep food fresh. This creates a biological tunnel from the bat's roost to the American breakfast table. The FDA and USDA have strict controls, but the gray market of food imports is vast. The philosophical implication here is the need for a sterile barrier between humanity and the wild food web. The fruit bat plays a crucial ecological role as a pollinator, but its virome is incompatible with human life. When we tap the tree, we are inserting ourselves into the bat's feeding cycle. The skirt or barrier methods now used in some agricultural practices, covering the collection pots with bamboo screens to prevent bat access, are effective but not universally adopted. Until they are, or until the consumption of raw sap is abandoned, the pot of sweet liquid remains a game of Russian roulette. The directive is clear: boil it or ban it. There is no middle ground with a biosafety level 4 pathogen.
Entry 4. The Universal Firewall. Practice frequent hand hygiene. The physics of decontamination. Entry number 4 is the most mundane yet scientifically profound weapon in the arsenal against Nipah, hand hygiene. While it sounds like a rudimentary public health slogan, in the context of a high-mortality virus, it is a complex decontamination protocol. The Nipah virus is an enveloped virus. Structurally, this means the genetic core of the virus is wrapped in a lipid bilayer, a fatty membrane derived from the host cell it burst out of. This envelope is studded with glycoproteins, G and F proteins, that allow the virus to dock and fuse with human cells. However, this lipid armor is also its fatal weakness. It makes the virus highly susceptible to the chemical action of surfactants, the active ingredients in soap. When you wash your hands with soap and water, you are not merely rinsing off the dirt, you are engaging in a chemical demolition of the virus. Soap molecules are amphiphiles. They have a water-loving, hydrophobic head and a fat-loving, hydrophobic tail. When you lather soap on your hands, the hydrophobic tails wedge themselves into the lipid envelope of the Nipah virus, prying it apart like a crowbar. Once the envelope is ruptured, the virus spills its genetic guts and becomes inert. It can no longer infect a cell. This process, however, is governed by thermodynamics in time. This is why the protocol specifies at least 20 seconds. It takes time for the soap molecules to fully coat the surface area of the hands, penetrate the viral clusters, and physically dismantle the lipid layers. A quick rinse is useless. It moves the virus around but does not destroy it. The fomite narrative in surface transmission. The necessity of this protocol stems from the concept of fomite transmission. A fomite is any inanimate object that, when contaminated with or exposed to infectious agents, can transfer disease to a new host. In a Nipah outbreak, the world becomes a landscape of potential fomites. A railing touched by a patient, a piece of fruit handled by a bat, a medical instrument, or even the clothing of a caregiver, all can harbor the virus. Nipah is resilient. Studies suggest it can survive on surfaces for days in fruit juice or mango flesh, and for prolonged periods in urine. Your hands are the primary interface between your body and this contaminated world. The average human touches their face, specifically the eyes, nose,
And mouth dozens of times per hour, often subconsciously. Every touch is a potential inoculation event. The what to do section for this entry emphasizes immediacy. Clean hands immediately after risky contact is the directive. This is not about waiting until you get home. If you touch a surface in a hospital, a stray animal, or a suspected contaminated fruit, the clock starts ticking. The virus is sitting on the keratinized layer of your skin, the epidermis, which is a dead layer and thus immune to infection. The danger is the transfer. You are one eye rub or finger lick away from infection. If soap and water are unavailable, alcohol-based hand sanitizers containing at least 60% alcohol are the secondary defense. Alcohol works by denaturing the proteins of the virus, essentially cooking it chemically. However, sanitizers have limitations. They are less effective if hands are visibly soiled with dirt or mucus, which can shield the virus from the alcohol. The psychological burden of the clean hands doctrine. Implementing this level of hygiene requires a psychological shift. It demands that one views their hands as biohazards until proven otherwise. In a high-risk scenario, such as caring for a sick relative or living in an outbreak zone, this can lead to hygiene fatigue. The human mind struggles to maintain high alert against an invisible enemy. Yet history dictates that compliance with hand hygiene is the single most effective factor in halting nosocomial, hospital-acquired transmission. During the Kerala outbreaks in India, strict adherence to barrier nursing and hand hygiene prevented the virus from exploding into the general population. The protocol also demands a technical precision that most people lack. It involves scrubbing the backs of the hands between the fingers, interlacing the thumbs and the fingertips. The fingertips are the most critical, as they are the primary tactile sensors and the most likely to touch the face. Rings and watches become reservoirs for pathogens and should be removed or sterilized. The prevention here is active, not passive. It is a constant rhythmic debridement of the body's primary tools. The post-COVID context and complacency. In the United States, the post-COVID era has created a paradox. While awareness of hand hygiene is higher, so is complacency. There is a sense that we survived the pandemic, so we can relax. Nipah does not allow for relaxation.
With a mortality rate that can range from 40% to 75%, it is exponentially more lethal than COVID-19. The margin for error is not existent. If Nipah were to establish a foothold in the US, the casual splash and dash hand washing that characterizes American public restroom behavior would be a death sentence. Furthermore, this entry extends to the hygiene of the tools we use. Mobile phones, for instance, are extensions of the hand. We wash our hands but rarely sanitize our phones, which we then press against our faces. To practice frequent hand hygiene in the context of Nipah means extending that hygiene to the personal devices that our hands constantly manipulate. The what to do instruction to clean hands immediately must be interpreted as a total decontamination of the manual interface. The future of contact. Ultimately, this entry forces us to reconsider the nature of human touch. In a viral age, touch is a transaction of biological data. To prevent Nipah, we must sanitize that transaction. This does not mean the end of intimacy or connection, but it necessitates a new etiquette of survival. When you wash your hands, you are not just protecting yourself, you are breaking a potential chain of transmission that could save hundreds of lives. You are acting as a biological firewall. The soap bubble is a microscopic shield, and the sink is the front line of the defense. In the absence of a vaccine, the humble bar of soap remains the most sophisticated technology we possess to sever the link between the reservoir and the host.
Entry 5. The intimacy trap. Avoid close contact with infected or suspected individuals. The shift from zoonosis to anthropognosis, the human amplifier. The fifth entry in this prevention protocol marks a terrifying pivot in the epidemiology of the Nipah virus. Up to this point, the focus has been on the spillover, the jump from the wild reservoir, bats, or the intermediate host, pigs, to the human patient. However, once the virus establishes itself within a human host, the rules of engagement change drastically. The virus undergoes a functional shift from zoonosis to anthropognosis, human-to-human transmission. This is the mechanism that transforms a tragedy into an epidemic. The directive to avoid close contact with infected or suspected individuals is not merely a suggestion of social distancing. It is a biological imperative to sever the chain of transmission before it creates a cluster bomb of infection. Unlike the Malaysian strain of 1998, which showed limited human-to-human transmission, the strains circulating in Bangladesh and India have evolved a terrifying capacity to jump between people, specifically exploiting the bonds of family and caregiving. To understand the gravity of this avoidance protocol, one must analyze the caregiver's curse. In almost every major outbreak of Nipah in South Asia, the secondary victims, those who caught the virus not from a bat but from a human, were family members and healthcare workers. The virus exploits human compassion. When a patient enters the acute phase of Nipah, they suffer from severe respiratory distress, violent coughing, and eventually a comatose state induced by encephalitis. These symptoms require intense, hands-on care. Family members wipe the brow, clear the vomit, hold the hand, and lean in close to hear the whispering of a delirious loved one. It is in these moments of intimacy that the virus strikes. The viral load in the respiratory secretions and saliva of a terminal Nipah patient is astronomically high. A single cough, a shared utensil, or the handling of soiled bed sheets without protection is sufficient to transfer the pathogen. The definition of close contact and the superspreader event. In the United States, the definition of close contact is often standardized by the CDC for pathogens like influenza or COVID-19, but Nipah demands a more rigorous interpretation. Close contact here involves unprotected exposure to the bodily fluids or respiratory droplets of a symptomatic person.
The danger zone is typically defined as being within 3 feet of the patient, but in enclosed, poorly ventilated spaces, this radius expands. The history of Nipah is scarred by superspreader events that defy standard transmission models. The most chilling example occurred in Siliguri, India in 2001. A single patient was admitted to a hospital with undiagnosed fever. Because Nipah was not suspected, no isolation protocols were in place. This one individual infected 33 other people, including staff and visitors, simply through the routine interactions of a hospital ward. This event proved that avoiding contact is not just about physical touch, it is about sharing air volume in a medical setting. For the average citizen, the difficulty lies in the suspected part of the directive. Nipah's early symptoms, fever, headache, muscle pain, sore throat, are indistinguishable from the common flu or COVID-19. This diagnostic ambiguity creates a window of extreme vulnerability. By the time the hallmark symptoms of drowsiness and mental confusion appear, the patient has likely been infectious for days. Therefore, in an outbreak scenario, the protocol of avoidance must be preemptive. Any individual displaying febrile symptoms in a risk area must be treated as a level 4 biohazard until proven otherwise. This requires a radical shift in social behavior. The instinct to comfort the sick must be suppressed and replaced with the instinct to isolate. Personal items, towels, glasses, phones must never be shared. The virus can persist on these surfaces, hitching a ride from the sick room to the healthy world. The protocol of isolation and the what to do algorithm.
If you suspect you have been in close contact with an infected individual, the What to Do protocol is a rigid algorithm of self-preservation and community defense. The first step is immediate self-isolation. This does not mean staying in the guest bedroom. It means creating a negative pressure environment if possible, or at the very least, a sealed zone where air exchange with the rest of the household is minimized. You effectively become a prisoner of your own biology. The psychological toll of this waiting period is immense. You are waiting for the prodrome, the first sign of fever. During this time, you must contact health authorities. In the US, this would involve alerting the CDC and local health departments,
who would likely dispatch a specialized team equipped with maximum containment gear to assess the situation. The medical response to a contact case involves aggressive contact tracing. Every person the suspect has interacted with must be mapped and monitored. This is a logistical nightmare but a necessity. The mortality rate of Nipah, 40 to 75%, allows for zero margin of error. If you were the contact, you must provide a detailed history of your movements. Did you share a meal? Did you embrace? Did you use the same restroom? The virus is excreted in urine, making shared bathrooms a high-risk vector. The instruction to seek medical advice is critical because while there is no cure, early supportive care, hydration, anticonvulsants can marginally improve survival odds. Furthermore, experimental treatments like the monoclonal antibody M102.4 are only effective if administered early in the infection window. Sociological implications, the death of the bedside vigil. The philosophical and cultural implication of this entry is the disruption of the good death. For centuries, humans have gathered around the dying to offer comfort. Nipah criminalizes this ritual. In a severe outbreak, the infected must die alone or surrounded by strangers in hazmat suits. The family must be kept behind glass. This is the brutal reality of managing a pathogen that transmits via close contact. The avoidance protocol forces society to choose between emotional closure and biological survival. In a potential US outbreak, this would clash violently with American notions of individual liberty and patient rights. The enforcement of isolation orders would require legal and police intervention. We saw the friction of this during the Ebola scares and the COVID-19 pandemic, but Nipah raises the stakes. The suspected individual becomes a pariah. The fear of contagion can lead to social stigmatization, where neighbors shun the families of the sick. This social fracturing is a secondary symptom of the virus. To prevent Nipah, one must be willing to erect a wall between oneself and the community, to view every cough as a threat and every fever as a potential apocalypse. It is a grim, paranoid way to live, but in the presence of a Nipah virus, paranoia is a survival trait. The future of preventing close contact transmission lies in rapid diagnostics. Currently, confirming Nipah takes time during which the virus spreads. If we can develop rapid
point-of-care tests similar to those for COVID, we can narrow the window of suspicion and allow for targeted isolation rather than blanket avoidance. Until then, the crude tool of physical distance remains our primary defense against the human amplifier.
Entry 6. The respiratory shield. Wear masks in crowded or high-risk areas. The physics of the aerosol and the mask as armor. Entry number 6 addresses the airborne dynamics of the Nipah virus and the critical role of respiratory protection. While Nipah is primarily classified as a droplet-transmitted disease, meaning it travels in large respiratory particles that fall to the ground quickly, there is growing evidence and concern regarding its potential for aerosolization, particularly in medical settings or crowded environments. The directive to wear masks is not a generic public health platitude. It is a specific countermeasure against the physics of a cough. When an infected individual coughs or sneezes, they expel a turbulent gas cloud containing thousands of droplets, ranging from visible spittle to microscopic aerosols. The Nipah virion, roughly 150 to 600 nanometers in diameter, rides inside these droplets like a pilot in a cockpit. A properly fitted mask functions as a depth filter. It is not a sieve, it is a maze of fibers. When a droplet carrying the virus hits the mask, it is trapped by a combination of mechanisms. Inertial impaction, the droplet is too heavy to weave through the fibers and slams into them. Interception, the droplet brushes against a fiber and sticks. And diffusion, for the smallest particles, Brownian motion causes them to jitter and get caught. In the case of N95 respirators, an electrostatic charge adds a fourth layer of defense, magnetically pulling particles out of the airstream. In high-risk areas, pig farms, bat-infested orchards, or hospitals treating encephalitis patients, the air itself is a hostile medium. The mask is the only barrier protecting the mucous membranes of the nose and mouth from direct inoculation. The high-risk designation, where the mask matters most. The protocol specifies crowded or high-risk areas. In the context of Nipah, this definition is specific. A high-risk area is any location where the interface between humans and the reservoir, bats, fegs/exenies, is active, or where infected humans are concentrated. In Bangladesh, this includes the date palm groves at dawn. In Malaysia, it was the pigsties. In a US scenario, this would apply to healthcare workers in isolation units, researchers in biosafety labs, and potentially agricultural workers in areas where Peter Post bats might migrate due to climate change.
Crowded markets in endemic regions are also danger zones because the density of people makes it impossible to maintain the 3-foot rule mentioned in Entry 5. If one person coughs in a packed market, the droplet spray can coat the faces of a dozen people instantly. The mask serves two functions: source control and personal protection. Source control is altruistic. If you are unknowingly incubating Nipah during the 4 to 14-day window, the mask traps your respiratory secretions, preventing you from infecting others. Personal protection is selfish. It blocks incoming projectiles. In the hierarchy of prevention, the N95 or N99 respirator is the gold standard. Surgical masks offer protection against large splashes but are loose-fitting. Aerosols can leak in through the gaps. Cloth masks are the least effective against a high-consequence pathogen like Nipah. The What to Do section emphasizes using properly fitted masks. A mask with a gap at the nose bridge is essentially a screen door on a submarine. Fit testing, a procedure used in hospitals to ensure a hermetic seal, becomes a life-saving ritual. The mechanics of exposure and mask management. The instruction to replace the mask immediately if exposed to droplets is crucial and often overlooked. A mask is a trap. Once it has intercepted a spray of droplets, the outer surface is highly contaminated. It becomes a fomite. If the mask becomes damp from breath or external fluids, its filtration efficiency plummets. Moisture breaks down the electrostatic charge of the fibers and creates a bridge for pathogens to migrate through the material by capillary action. Therefore, mask discipline is as important as mask wearing. One must never touch the front of the mask. Doffing, removing the mask, requires handling it only by the straps, pulling it away from the face, and immediately discarding it into a biohazard receptacle. This entry also touches on the concept of mask fatigue. In the wake of the COVID-19 pandemic, the world is exhausted by masking mandates. However, Nipah does not care about political fatigue. Its fatality rate demands a level of adherence that COVID did not. In a Nipah outbreak, the mask is not a temporary inconvenience, it is a component of a survival suit. The What to Do protocol implies a constant state of readiness. If you are in a risk zone, the mask goes on before you enter and comes off only after you have exited and decontaminated.
The hospital as the battleground, nosocomial defense. The most critical application of this entry is in the hospital setting. The history of Nipah is a history of nosocomial, hospital-acquired outbreaks. In Siliguri and Kerala, nurses and doctors died because they treated Nipah patients without adequate respiratory protection, often mistaking the early symptoms for malaria or routine encephalitis. Intubation, the process of inserting a breathing tube, is an aerosol-generating procedure. It turns the patient's throat into a viral volcano. During these procedures, standard surgical masks are useless. Healthcare workers must wear powered air purifying respirators or PAPRs or full-face N95s. The What to Do guideline for the public involves recognizing these environments. If you must visit a hospital during an outbreak, you are entering the hot zone. The waiting room is a mixing vessel for the sick. Wearing a high-grade mask here is non-negotiable. Furthermore, if you are the one coughing, the mask is your moral obligation. It prevents the hospital from becoming a super spreader site. The future of respiratory defense. Looking forward, the technology of the mask is evolving. We are moving towards smart masks equipped with biosensors that can detect viral particles in real time, changing color or sending an alert to a smartphone. Such technology would revolutionize the prevention of Nipah. Imagine a mask that warns you when you have entered a cloud of pathogens. Until that science fiction becomes reality, we rely on the mechanical filtration of melt-blown polymers. Culturally, the acceptance of masking in high-risk agricultural and medical settings must be normalized as a permanent safety standard, not just a crisis response. The bat populations are moving and the viruses are moving with them. The air between us is no longer empty space. It is a potential highway for contagion. The mask blocks the on-ramp. It is a simple, low-tech piece of fabric that stands between the intricate biology of the human lung and the devastating genetic code of the Nipah virus. To wear it is to acknowledge the reality of the invisible war we are fighting. To refuse it in a high-risk area is to surrender your primary shield.
Entry number 7, the culinary firewall in the defense against the Nipah virus. To fully grasp the necessity of thoroughly cooking animal-based foods, specifically pork, one must revisit the catastrophic genesis of the 1998 Malaysian outbreak. This event fundamentally rewrote the textbook on zoonotic spillover. While fruit bats are the natural reservoir, they possess a viral load that is often low and episodically shed. The pig, however, acts as an amplifier host. When a pig consumes bat-bitten fruit or comes into contact with bat urine in a sty, the virus does not merely survive, it thrives. The porcine physiology allows the Nipah virus to replicate at terrifying velocities, filling the animal's respiratory tract, saliva, and tissues with a viral concentration millions of times higher than that found in a bat. Consequently, the pig becomes a biological dirty bomb. In 1998, this resulted in a mass culling of over 1 million pigs to stop the spread. But for the consumer, the danger lies in the meat itself. While Nipah is primarily a respiratory and neurotropic virus, systemic infection means the pathogen permeates the blood and tissues of the animal. If an animal is slaughtered while in the viremic phase, the period when the virus is circulating in the bloodstream, the raw meat is effectively a biohazard. This is not a theoretical risk, it is a documented pathway of exposure for abattoir workers and those who handle raw animal products. The directive to cook thoroughly is the final line of defense against this amplified viral load. It is the application of thermodynamics to biology, using heat to dismantle the molecular machinery of the pathogen before it can enter the human system. The thermodynamics of viral destruction. The science of cooking in the context of virology is the science of protein denaturation.
The Nipah virus is an enveloped RNA virus. Its genetic core is protected by a lipid bilayer studded with glycoproteins, G and F proteins, that are essential for attaching to and fusing with host cells. These structures are heat-labile, meaning they are chemically unstable at high temperatures. When meat is subjected to heat, the kinetic energy of the molecules increases violently. At specific thermal thresholds, the weak hydrogen bonds holding the viral proteins in their specific 3D shapes shatter, the proteins unravel,
or denature, rendering the virus incapable of unlocking a human cell. The protocol demands a core temperature of at least 70 degrees Celsius, 158 degrees Fahrenheit, for all animal-based foods. This is the kill zone. At this temperature, the lipid envelope melts and dissolves, and the internal RNA is exposed and degraded. However, the term thoroughly is the operative variable. A sear on the outside of a pork chop does not guarantee the sterilization of the center if the animal was systemically infected. The virus can survive in the cool, bloody center of a rare cut. In a Nipah and chemic world, the culinary preference for rare or medium-rare pork, a trend in some high-end gastronomical circles, becomes a game of Russian roulette. The heat must penetrate the geometric center of the food mass. This requires time and sustained temperature, ensuring that every molecule of the meat reaches the thermal death point of the virus. The kitchen as a biosafety level 2 laboratory. The danger, however, often precedes the cooking. The preparation of raw meat is a critical flashpoint for transmission. This is the concept of cross-contamination. When a knife slices through a piece of raw infected pork, it releases fluids, blood, lymph, and interstitial fluid, that may be teeming with live virus. These fluids can splatter onto countertops, cutting boards, and the hands of the cook. If a person wipes their hand on a towel and then touches their face, the infection pathway is complete without a single bite of food being consumed. This was a suspected vector in abattoir infections, where the aerosolization of blood during slaughter infected workers. In the domestic kitchen, the what to do protocol involves treating raw meat with the same caution one would handle toxic waste. Porous cutting boards like wood can trap viral particles in their grooves, protecting them from a quick wipe. The protocol mandates the use of non-porous boards, plastic or brass, that can be bleached. It dictates a rigid separation of raw and cooked foods. The sanitization of kitchen surfaces mentioned in the directive is not just about wiping up crumbs, it is about chemical decontamination of the preparation zone. If you are handling meat in a high-risk area, you are essentially a lab technician. The knife, the board, and the counter must be sterilized immediately after the meat hits the pan. The U.S. agricultural context and the nightmare scenario.
Applying this to the United States requires a look at the industrial scale of American agriculture. The U.S. is a massive producer of pork, with concentrated animal feeding operations, CAFOs, housing thousands of animals in close quarters. If Nipah were to enter this system, perhaps through a bat in a feed shed or an imported case, the spread would be explosive. The American food supply chain is highly centralized. A single infected processing plant could distribute contaminated meat across the continent in days. While the U.S. Department of Agriculture, USDA, has stringent inspections, Nipah is a stealth agent. Pigs can shed the virus while displaying only mild respiratory symptoms, often dismissed as porcine respiratory and reproductive syndrome, or PRRS, or swine flu. In such a scenario, the instruction to cook thoroughly becomes the only defense for the consumer against a failure in the industrial safety net. It shifts the burden of biosecurity from the government to the home cook. This entry also forces a reevaluation of bushmeat or game meat. In the U.S., hunting is a popular pastime. Venison, wild boar, and other game are often consumed. Wild boars in particular are biologically similar to domestic pigs and could theoretically serve as a reservoir if the virus established itself in the wild. The hunter who dresses a carcass in the field is at extreme risk, and the meat they bring home must be subjected to the same rigorous thermal treatment. The cultural shift, the end of the bloody aesthetic. The implementation of this protocol involves a cultural sacrifice. Culinary traditions often celebrate the texture and flavor of lightly cooked meats. To prevent Nipah, these traditions must be suspended. The well-done mandate is often derided by chefs as a destruction of flavor, but in the hierarchy of survival, flavor is a luxury. We must learn to view food not just as sustenance or art, but as a potential vector. Furthermore, the What to Do section advises discarding unsafe food. This triggers the instinct against food waste. If a piece of meat smells off or if its provenance is unsure, the human tendency is often to cook the hell out of it and eat it. Nipah protocols advise against this risk. While heat kills the virus, the handling required to cook the meat exposes the cook to the pathogen, if the safety of the raw ingredient is in question.
The only safe action is disposal, incineration, or deep burial to prevent it from entering the local ecosystem, e.g. being eaten by a stray cat or dog, which could then become a bridge host. Future implications: irradiated meat and lab-grown alternatives. Looking to the future, the threat of viruses like Nipah may accelerate the adoption of food irradiation. Irradiation involves exposing meat to ionizing radiation, gamma rays or X-rays, to destroy pathogens without using heat. While controversial due to public fear of radiation, it is a proven method for sterilizing raw meat. If Nipah becomes a global endemic threat, we may see cold pasteurized or irradiated pork becoming the standard in supermarkets, providing a safety buffer before the consumer even opens the package. Additionally, this risk drives the argument for lab-grown or cultured meat. Cultured meat is produced in a sterile bioreactor, completely divorced from the messy biological reality of a living animal, with a respiratory system and an immune system. There are no bats in a bioreactor. There is no spillover. The transition to cellular agriculture may ultimately be the only way to guarantee a meat supply chain free from zoonotic pathogens like Nipah. Until that technological utopia arrives, however, the safety of the human population rests on a simple ancient principle. Fire purifies. The heat of the skillet is the barrier between the virus and the vein.
The persistence of the invisible enemy. Entry number 8 confronts the environmental resilience of the Nipah virus. While often categorized as a direct contact pathogen, Nipah possesses a frightening capability for environmental persistence, particularly in favorable conditions. This brings us to the concept of the fomite, an inanimate object that becomes a vector for disease. In the cool, humid conditions often found in outbreaks, or in the climate-controlled environments of modern homes and hospitals, the virus can remain viable on surfaces for prolonged periods, up to several days in fruit juice or sap, and roughly 18 to 24 hours on hard surfaces, depending on viral load and organic matter presence. The directive to disinfect frequently touched surfaces is a declaration of chemical warfare against an invisible occupying force. The virus settles on doorknobs, light switches, remote controls, bed rails, and mobile phones. These are the high-traffic intersections of the microbial world. Every time a hand touches a surface, it leaves a residue of oils, moisture, and skin cells, a biofilm that can protect a virus. If an infected individual coughs into their hand and then opens a door, that doorknob becomes a biological landmine for the next person who turns it. The next person touches the knob, then rubs their eye, and the transmission chain is complete. This indirect transmission is insidious because the victim never needs to see the infected person. They are separated by time, connected only by the surface. The chemistry of disinfection, oxidative stress, and protein denaturation. To understand how to fight this, one must understand the weaponry. The protocol calls for disinfectants, but not all cleaners are created equal. Soap cleans, it removes dirt and grease. Disinfectants kill. The gold standard for destroying the Nipah virus on surfaces is sodium hypochlorite, common household bleach. When bleach is dissolved in water, it forms hypochloric acid, a potent oxidizer. This molecule attacks the lipid envelope of the virus and the proteins of its capsid. It essentially burns the virus on a molecular level, causing the protein coat to clump together, coagulate, and the genetic material to shatter. For surfaces that cannot handle bleach, like electronics or fabrics, alcohol solutions, 70% ethanol or isopropanol, are the required munition.
Alcohol works by dehydration and denaturation. It strips the water molecules away from the viral proteins, causing them to lose their structure and collapse. However, the concentration matters. Pure alcohol, 100%, evaporates too quickly to kill effectively. The presence of water in a 70% solution slows evaporation, allowing the alcohol to penetrate the viral envelope. Quaternary ammonium compounds, quats, found in many commercial wipes, are also effective, acting as surfactants that disrupt the cell membrane. The contact time fallacy and proper protocol. The most critical failure in surface disinfection is the violation of wet contact time. Most people spray a surface and immediately wipe it dry. This is hygiene theater. It looks like cleaning, but it accomplishes little biologically. For a disinfectant to kill the Nipah virus, it must remain wet on the surface for a specific duration, typically 1 to 10 minutes depending on the chemical. This dwell time allows the chemical reaction to occur. If the surface dries too fast, the virus may survive in a stunned but viable state. The what-to-do protocol of clean daily escalates to increase cleaning if someone is sick. In an outbreak scenario, this means creating a sanitization schedule. High-touch surfaces must be disinfected not just once a day, but after every use by a suspected person. This transforms the home into a clinical environment. The use of dispensable wipes is preferred over reusable cloths, which can spread the virus from one room to another if not laundered in hot water. This is the bucket vector problem. Dipping a dirty rag into a bucket of cleaning solution eventually contaminates the solution itself. The hospital connection, nosocomial nightmares. The historical context of this entry is rooted in the nosocomial, hospital-acquired transmission that defined the Kerala and Siliguri outbreaks. In these cases, the virus moved from patient to patient, not just through the air, but through the environment. Bed rails, IV stands, and shared medical equipment became vectors. In Siliguri, the lack of rigorous surface disinfection allowed the virus to sweep through the ward. The lesson learned was that in a Nipah ward, the environment is as infectious as the patient. In the United States, where hospitals are busy and turnover is high, the rigor of terminal cleaning, the deep clean performed after a patient is discharged, would need to be elevated to Ebola-level standards.
This involves using UVC robots, machines that blast a room with ultraviolet light to shatter viral DNA, and vaporized hydrogen peroxide systems that fog a room to sterilize every nook and cranny. For the average citizen, this underscores the danger of healthcare facilities during an outbreak. The waiting room chair is a fomite. The elevator button is a fomite. The magazine on the table is a fomite. The psychology of the clean home. Implementing this level of disinfection takes a psychological toll. It creates a mindset where the physical world is viewed with suspicion. This fomite paranoia can be exhausting, but it is necessary. It requires a mental mapping of one's own movements. I touched the mail, now I must sanitize the counter where I placed it. It changes the relationship with the home environment. Soft surfaces, couches, carpets, curtains are notoriously difficult to disinfect. In a high-risk scenario, the protocol often suggests covering these surfaces with plastic or removing them entirely to create a hard environment that can be chemically scorched. This entry also covers the increased cleaning if someone at home is sick directive. This implies the creation of a hot zone, the sick room, and a cold zone, the rest of the house. Nothing moves from hot to cold without passing through a disinfection checkpoint. Dishes used by the sick person must be soaked in bleach solution before being washed. Laundry must be handled with gloves and washed at the highest temperature. The trash from the sick room is biohazard waste. It must be double bagged and the exterior of the bag sprayed with bleach before disposal. The future, the self-sterilizing city. The threat of persistent viruses like Nipah is driving innovation in material science. We are moving toward the concept of the self-sterilizing city. Research is accelerating into antimicrobial coatings, surfaces infused with copper or silver ions that actively kill viruses on contact. Copper, for example, has a halo effect where it releases ions that destroy viral DNA/RNA within minutes. In the future, doorknobs, subway poles, and hospital trays may be made of copper alloys or coated with photocatalytic materials, like titanium dioxide, that generate free radicals when hit by light, continuously burning away pathogens. Until these passive defenses are built into our infrastructure, active disinfection remains our duty. We are the custodians of our own biosecurity.
The spray bottle and the bleach wipe are not merely cleaning supplies, they are the tools of containment. By destroying the virus on the handle of a door, you are preventing it from shaking the hand of the next victim. It is a tedious, repetitive, and invisible battle, but it is one that cuts the supply lines of the virus, starving it of new hosts. In the war against Nipah, a wet, bleached surface is a shield as strong as steel. Entry number 9, the biological alarm. Seek medical care if symptoms appear. The prodromal deception, the mask of the virus. Entry number 9 is the pivot point between prevention and survival. It addresses the moment the perimeter has been breached, when the virus has successfully navigated the environmental defenses, bypassed the hygiene protocols, and established a beachhead within the human host. The directive to seek medical care if symptoms appear seems on the surface to be a standard medical platitude. However, in the context of the Nipah virus, this instruction is a race against a biological clock that is ticking down toward catastrophic neurological failure. The tragedy of Nipah lies in its initial ambiguity. The virus is a master of camouflage. Its incubation period is erratic, ranging from 4 and 14 days, though cases of incubation lasting up to 45 days have been documented. During this silent phase, the virus is replicating, hijacking the cellular machinery, and spreading through the bloodstream. When the prodrome, the early phase of symptoms, finally manifests, it does not announce itself as a level 4 biohazard. It presents as a mundane, non-specific illness: fever, headache, muscle pain, myalgia, vomiting, and a sore throat. This is the mask of benignity. To the average American citizen, or even the average primary care physician during flu season, these symptoms scream influenza or COVID-19. This diagnostic confusion is the virus's greatest tactical advantage. It buys the pathogen time to multiply unchecked before specific containment measures are enacted. The prevention aspect of this entry is actually prevention of mortality and prevention of secondary transmission. It relies on a hyper-vigilant self-awareness. If an individual has been in a high-risk area, has consumed date palm sap, or has been near livestock, a fever is never just a fever. It is a potential sentinel event. The neurotropic assault, crossing the blood-brain barrier. The urgency to seek medical care is driven by the virus's devastating pathophysiology. Nipah is a systemic infection, but it is aggressively neurotropic, meaning it has a predilection for the nervous system. Unlike respiratory viruses that stay in the lungs, Nipah uses the bloodstream as a highway to reach its primary target, the brain. It binds to the ephrin B2 and ephrin B3 receptors, which are abundantly expressed on the endothelial cells of the blood vessels and the neurons themselves.
Once it breaches the blood-brain barrier, the physiological fortress meant to protect the brain from toxins, the clock accelerates. The transition from the flu-like phase to the encephalitic phase can happen with terrifying speed, often within 24 to 48 hours of the first symptom. This is characterized by dizziness, drowsiness, altered consciousness, and neurological signs that indicate the brain is swelling, encephalitis. The patient may become disoriented, unable to recognize family members, or slip into a coma. In the Bangladesh and India outbreaks, this rapid deterioration was often the first indication to doctors that they were not dealing with malaria or typhoid. By the time a patient is comatose, the mortality rate spikes to nearly 75%. Therefore, the what to do protocol emphasizes immediacy. You do not wait for the confusion to set in. You go to the hospital at the first spike of fever if your exposure history warrants suspicion. The goal is to be in a high-dependency unit before the brain begins to swell, allowing doctors to prepare for the onslaught. The respiratory variants and the ARDS crisis.
While the brain is a primary target, the lungs are often the battlefield where the war is lost. This is particularly true of the Bangladesh strain of the virus, which is more prone to causing severe respiratory disease than the Malaysian strain. The virus attacks the epithelial cells of the respiratory tract, causing a massive inflammatory response known as a cytokine storm. The immune system, in a panic to kill the intruder, floods the lungs with fluid and immune cells, drowning the patient from the inside. This is acute respiratory distress syndrome. Seeking medical care immediately allows for the early administration of respiratory support. This might begin with supplemental oxygen but often escalates to mechanical ventilation. In a U.S. context where advanced critical care is available, early intubation can buy the patient time for their immune system to mount a defense. However, this also presents a supreme danger to the medical staff. A patient in respiratory distress is coughing, spluttering, and aerosolizing the virus. If the patient arrives at the ER and sits in a waiting room for hours without disclosing their risk history, they become a superspreader. The protocol, therefore, includes a crucial communicative step: inform a healthcare provider. You must verbally flag yourself as a potential Nipah case immediately upon arrival.
This triggers the isolation algorithm, moving the patient from the public waiting area to a negative pressure room, protecting the hospital ecosystem. The specter of relapsing encephalitis. One of the most haunting aspects of the Nipah virus and a critical reason for long-term medical monitoring is the phenomenon of relapsing encephalitis. Nipah is one of the few viruses known to science that can go dormant in the human central nervous system. A patient can survive the acute infection, recover, and return to their normal life, only to have the virus reactivate months or even years later. This is known as the late onset form. The virus hides in immunologically privileged sites within the brain, evading the antibodies circulating in the blood. Then, triggered by stress or unknown factors, it flares up again, causing a sudden, often fatal encephalitis. This biological horror story underscores why seeking medical care is not a one-time event. It is the beginning of a lifelong relationship with infectious disease specialists. Survivors of Nipah often suffer from long-term neurological sequelae, including persistent convulsions and personality changes. The What to Do protocol extends beyond the acute phase to a regimen of regular MRI scans and neurological assessments. In the U.S., a survivor would likely be entered into a long-term study protocol, their blood and spinal fluid monitored for viral RNA or rising antibody titers that might signal a reactivation. The decision to go to the hospital is not just about saving your life today, it is about documenting the infection so that if you collapse 4 years later, the doctors know to look for a ghost from the past. The therapeutic void and the experimental frontier. The grim reality that confronts the patient upon admission is that there is no licensed cure for Nipah. There is no antiviral drug sitting on the shelf that acts as a silver bullet. The treatment is primarily supportive care. This sounds passive, but in a modern ICU, it is an aggressive, high-tech war of attrition. It involves managing the intracranial pressure to prevent the brain from crushing itself against the skull, balancing electrolytes, preventing secondary bacterial infections, and maintaining organ perfusion. However, seeking care immediately opens the door to compassionate use protocols. This is where the cutting edge of science meets the desperation of the clinic. There are experimental treatments in development.
The most promising is a monoclonal antibody known as M102.4. This laboratory-engineered protein mimics the human receptor the virus targets, essentially tricking the virus into binding to the drug instead of the patient's cells. It has shown success in animal models and has been used in a handful of human cases on a compassionate basis. Another potential therapeutic is remdesivir, the broad-spectrum antiviral used during the COVID-19 pandemic, which has shown some efficacy against heniviruses in primate studies. These experimental drugs are not available at a local urgent care clinic. They are accessible only at major academic medical centers in coordination with the CDC. By delaying care, a patient effectively disqualifies themselves from the window of opportunity where these experimental countermeasures might work. The prevention of death here relies on the speed of access to the highest tier of medical intervention.
Entry 10. The Macro Defense. Follow health authority guidelines. The architecture of collective survival. The final entry in the top 10 ways to prevent Nipah virus is the overarching canopy that shelters all other protocols. Follow health authority guidelines is the shift from individual agency to collective survival. In the context of a high-mortality zoonotic pathogen, the individual cannot exist in a vacuum. A single person's refusal to comply with quarantine, testing, or travel restrictions can unravel the safety of an entire nation. The Nipah virus, with its potential for human-to-human transmission and its high case fatality rate, poses an existential threat that requires a command-and-control response. The guidelines issued by bodies like the Centers for Disease Control and Prevention, CDC, the World Health Organization, WHO, and local health departments are not suggestions. They are the operational doctrine of the war against the virus.
This entry investigates the complex machinery of public health and the critical role of the citizen within it. When an outbreak is detected, whether it is a cluster of encephalitis cases in Kerala or a theoretical importation into the United States, health authorities activate an Incident Management System, IMS. This system generates the guidelines based on real-time epidemiological data. These guidelines cover everything from the definition of a suspect case to the specific type of PPE required for burial teams. Following these instructions is the only way to synchronize the behavior of millions of people to break the chain of transmission. The prevention here is the prevention of chaos and the prevention of the epidemic curve from going vertical. The Information War, battling the infodemic. In the modern era, the greatest enemy of guideline adherence is the infodemic, the rapid spread of misinformation, rumors, and conspiracy theories. During the COVID-19 pandemic, we witnessed how disinformation could lead to resistance against masks, vaccines, and isolation. With Nipah, the stakes are exponentially higher. A mortality rate of 70% leaves no room for alternative facts. If a rumor spreads that eating raw garlic cures Nipah or that the virus is a hoax, people will die. They will engage in risky behaviors, ignore symptoms, and bypass the medical system until it is too late. The What to Do protocol emphasizes staying informed through official sources.
This requires a disciplined filtration of one's information diet. It means tuning out the noise of social media pundits and tuning into the briefings of virologists and epidemiologists. In a Nipah scenario, the CDC would likely issue daily situation reports, SITREPs. These documents contain the truth of the outbreak, where the hot zones are, which behaviors are currently driving transmission, and what the specific legal requirements are for isolation. Compliance is an intellectual act. It involves acknowledging that the experts possess a situational awareness that the individual does not. The guideline to avoid public gatherings might seem oppressive, but it is based on mathematical models of viral reproduction, are not. To follow it is to trust the math over the instinct to socialize. The mechanics of containment, testing, isolation, and surveillance. The practical application of following guidelines involves submitting to the rigors of surveillance. This is the intrusive side of public health. If you are identified as a contact of a Nipah patient, the guidelines will dictate that you be monitored. This is not passive. It involves active monitoring, daily temperature checks, symptom diaries, and potentially confinement to a quarantine facility. In the U.S., public health laws grant authorities the power to detain individuals who pose a threat to public health. While this tension between civil liberty and biosecurity is palpable, the history of Nipah outbreaks proves that strict quarantine is the only way to stop the burn. Testing is another pillar of compliance. The guidelines will dictate who gets tested and when. Because Nipah diagnostics, RT-PCR, are specialized and not available at every corner pharmacy, the allocation of tests is strategic. Demanding a test when you are asymptomatic and low risk clogs the system. Refusing a test when you are symptomatic blinds the system. Compliance means accepting the triage decisions of the authorities. It also involves the ring strategy. If a vaccine were to be developed, several are in the pipeline, health authorities would likely deploy it in a ring around known cases, vaccinating contacts and contacts of contacts. Following guidelines would mean accepting this investigational vaccine to create an immunological firewall. The One Health paradigm, the ultimate guideline.
Health authorities now recognize that human health is inextricably linked to the health of animals and the environment. The guidelines for preventing Nipah are not just about washing hands. They are about land use, deforestation, and animal husbandry. The ultimate guideline is to respect the ecological boundaries that keep these viruses contained in their natural reservoirs. In a U.S. context, this translates to agricultural regulations. If the USDA issues a guideline to secure pig feed from wildlife access, a farmer's compliance is a matter of national security. If the Fish and Wildlife Service issues guidelines about not disturbing bat roosts, a hiker's compliance prevents the stress-induced viral shedding that starts the spillover. Following guidelines means participating in a holistic defense strategy that spans species. It is an acknowledgement that we are not the masters of nature, but merely participants in a fragile biological web. The future of biosecurity and the social contract. As we look to the future, the Follow Health Authority Guidelines entry represents the evolving social contract of the 21st century. We are entering an era of pandemics. The frequency of zoonotic spillover is increasing due to climate change, urbanization, and travel. Nipah is currently a localized threat with global potential. If it were to adapt for more efficient human transmission, it would represent a civilization-level threat. In such a scenario, the cohesion of society, the willingness of the citizenry to move as one organism in response to guidance, is the single greatest predictor of survival. The What to Do instruction to comply with testing, isolation, and treatment instructions is a call to civic duty. It asks the individual to endure temporary hardship, isolation, economic loss, restriction of movement, for the permanent safety of the collective. It is the modern equivalent of the blackout curtains used during wartime air raids. The virus is the bomber overhead, the guideline is the siren. To ignore it is to invite destruction. Conclusion: the fragile shield. This investigation into the top 10 ways to prevent Nipah virus concludes with a sobering realization. We have no cure, we have no approved vaccine, we only have our behavior. From the avoidance of the bat in the canopy, entry 1, to the compliance with the public health official on the news, entry 10, every step of this protocol is a behavioral modification.
We are building a shield out of habits, decisions, and knowledge. The Nipah virus is a biological machine refined by millions of years of evolution to exploit our weaknesses, our hunger for fruit, our love for our families, our need to breathe, and our tendency to ignore invisible threats. To prevent it, we must be smarter than the virus. We must be rigorous, disciplined, and united. The defense against Nipah does not begin in a laboratory, it begins in the mind of the individual who decides to peel the fruit, wash their hands, wear the mask, and listen to the science. The virus is waiting for a mistake. The prevention is to never make one. Entry 10. The Macro Defense. Follow health authority guidelines. The architecture of collective survival. The final entry in the top 10 ways to prevent Nipah virus is the overarching canopy that shelters all other protocols. Follow health authority guidelines is the shift from individual agency to collective survival. In the context of a high-mortality zoonotic pathogen, the individual cannot exist in a vacuum. A single person's refusal to comply with quarantine, testing, or travel restrictions can unravel the safety of an entire nation. The Nipah virus, with its potential for human-to-human transmission and its high case fatality rate, poses an existential threat that requires a command-and-control response. The guidelines issued by bodies like the Centers for Disease Control and Prevention, CDC, the World Health Organization, WHO, and local health departments are not suggestions. They are the operational doctrine of the war against the virus. This entry investigates the complex machinery of public health and the critical role of the citizen within it. When an outbreak is detected, whether it is a cluster of encephalitis cases in Kerala or a theoretical importation into the United States, health authorities activate an Incident Management System, IMS. This system generates the guidelines based on real-time epidemiological data. These guidelines cover everything from the definition of a suspect case to the specific type of PPE required for burial teams. Following these instructions is the only way to synchronize the behavior of millions of people to break the chain of transmission. The prevention here is the prevention of chaos and the prevention of the epidemic curve from going vertical. The Information War, battling the infodemic. In the modern era, the greatest enemy of guideline adherence is the infodemic, the rapid spread of misinformation, rumors, and conspiracy theories. During the COVID-19 pandemic, we witnessed how disinformation could lead to resistance against masks, vaccines, and isolation. With Nipah, the stakes are exponentially higher. A mortality rate of 70% leaves no room for alternative facts. If a rumor spreads that eating raw garlic cures Nipah or that the virus is a hoax, people will die. They will engage in risky behaviors, ignore symptoms, and bypass the medical system until it is too late. The What to Do protocol emphasizes staying informed through official sources.
This requires a disciplined filtration of one's information diet. It means tuning out the noise of social media pundits and tuning into the briefings of virologists and epidemiologists. In a Nipah scenario, the CDC would likely issue daily situation reports, SITREPs. These documents contain the truth of the outbreak, where the hot zones are, which behaviors are currently driving transmission, and what the specific legal requirements are for isolation. Compliance is an intellectual act. It involves acknowledging that the experts possess a situational awareness that the individual does not. The guideline to avoid public gatherings might seem oppressive, but it is based on mathematical models of viral reproduction, are not. To follow it is to trust the math over the instinct to socialize. The mechanics of containment, testing, isolation, and surveillance. The practical application of following guidelines involves submitting to the rigors of surveillance. This is the intrusive side of public health. If you are identified as a contact of a Nipah patient, the guidelines will dictate that you be monitored. This is not passive. It involves active monitoring, daily temperature checks, symptom diaries, and potentially confinement to a quarantine facility. In the U.S., public health laws grant authorities the power to detain individuals who pose a threat to public health. While this tension between civil liberty and biosecurity is palpable, the history of Nipah outbreaks proves that strict quarantine is the only way to stop the burn. Testing is another pillar of compliance. The guidelines will dictate who gets tested and when. Because Nipah diagnostics, RT-PCR, are specialized and not available at every corner pharmacy, the allocation of tests is strategic. Demanding a test when you are asymptomatic and low risk clogs the system. Refusing a test when you are symptomatic blinds the system. Compliance means accepting the triage decisions of the authorities. It also involves the ring strategy. If a vaccine were to be developed, several are in the pipeline, health authorities would likely deploy it in a ring around known cases, vaccinating contacts and contacts of contacts. Following guidelines would mean accepting this investigational vaccine to create an immunological firewall. The One Health paradigm, the ultimate guideline.
Health authorities now recognize that human health is inextricably linked to the health of animals and the environment. The guidelines for preventing Nipah are not just about washing hands. They are about land use, deforestation, and animal husbandry. The ultimate guideline is to respect the ecological boundaries that keep these viruses contained in their natural reservoirs.
In a U.S. context, this translates to agricultural regulations. If the USDA issues a guideline to secure pig feed from wildlife access, a farmer's compliance is a matter of national security. If the Fish and Wildlife Service issues guidelines about not disturbing bat roosts, a hiker's compliance prevents the stress-induced viral shedding that starts the spillover. Following guidelines means participating in a holistic defense strategy that spans species. It is an acknowledgement that we are not the masters of nature, but merely participants in a fragile biological web. The future of biosecurity and the social contract. As we look to the future, the Follow Health Authority Guidelines entry represents the evolving social contract of the 21st century. We are entering an era of pandemics. The frequency of zoonotic spillover is increasing due to climate change, urbanization, and travel. Nipah is currently a localized threat with global potential. If it were to adapt for more efficient human transmission, it would represent a civilization-level threat. In such a scenario, the cohesion of society, the willingness of the citizenry to move as one organism in response to guidance, is the single greatest predictor of survival. The what to do instruction to comply with testing, isolation, and treatment instructions is a call to civic duty. It asks the individual to endure temporary hardship, isolation, economic loss, restriction of movement, for the permanent safety of the collective. It is the modern equivalent of the blackout curtains used during wartime air raids. The virus is the bomber overhead, the guideline is the siren. To ignore it is to invite destruction. Conclusion: the fragile shield. This investigation into the top 10 ways to prevent Nipah virus concludes with a sobering realization. We have no cure, we have no approved vaccine, we only have our behavior. From the avoidance of the bat in the canopy, entry 1, to the compliance with the public health official on the news, entry 10, every step of this protocol is a behavioral modification.
We are building a shield out of habits, decisions, and knowledge. The Nipah virus is a biological machine refined by millions of years of evolution to exploit our weaknesses, our hunger for fruit, our love for our families, our need to breathe, and our tendency to ignore invisible threats. To prevent it, we must be smarter than the virus. We must be rigorous, disciplined, and united. The defense against Nipah does not begin in a laboratory, it begins in the mind of the individual who decides to peel the fruit, wash their hands, wear the mask, and listen to the science. The virus is waiting for a mistake. The prevention is to never make one.